Use the data in the following table, which lists survey results from high school drivers at least 16 years of age. Assume that subjects are randomly selected from those included in the table. So in the rows, we have texted while driving, no texted while driving. In the columns, we have yes or no. And it states here that if 4 different high school drivers are randomly selected, find the probability that they all drove when drinking alcohol. Okay, so the first thing we should do is we want to find the total of the columns and then find the total of the rows. So if we want to find the total of the columns, if we take 698 and add 137, then we're going to get a total of 835. If we take 2,906 and add that with 4,347, then we're going to get the total of 7,253. Now we want to find the total of the rows. So if we take 698 and add 2,906, we get 3,604. If we take 137 and add 4,347, then that's going to give us a total of 4,484 that no texted while driving. Now we want to find the total of all that were surveyed in this study. So if we add 835 with 7,253, so let's go ahead and do that. 835 plus 7,253, we get 8,088. If we add the columns as well, 3604 plus 4484, we should get the same amount. So therefore, that is the total that has been surveyed in this entire study. Okay, now, the formal multiplication rule tells us that the probability of A and B is the probability of both A and B occurring, which is equal to the probability of A, which is the probability of event A occurring, times the probability of event B occurring, given that A has already occurred. Now, we want to first find the probability that one randomly selected high school driver drove when drinking alcohol. So the first thing we're going to do is we're going to let X equal the total students who drove when drinking alcohol. We're going to let N equal the total number of high school drivers in this survey. So we want to find the probability of one high school driver who drove when drinking alcohol is X over N. Okay, so going back to our problem up here, we know that the total of X students who drove when drinking alcohol had stated yes in this column, and that total was 835. So we can see that X equals 835 are the students who drove when drinking alcohol. Okay, and then the total number of high school students or high school drivers in this survey is N is equal to 8,088. So we want to determine the fraction to find the probability that one randomly selected high school driver drove when drinking alcohol. So we know the following. We know that X, which is 835, we would divide that by the total, which is 8,088. Now this is the fraction of one randomly selected high school student. Okay, in our question, we're looking for 4, right? So since there's 4, we need to consider the value of the probability of event B, provided that A has already occurred. We want to take that into account whether or not A and B are dependent events. Now, 2 events A and B are independent if the occurrence of one does not affect the probability of the occurrence of the other. If A and B are not independent, then they are said to be dependent. Now, the selection of the first high school driver does affect the probability of the outcome of the next high school driver because they are dependent events. So the same high school driver cannot be selected more than once. However, the probability of each driver being randomly selected will not be exactly the same because the events are dependent. However, the total number of high school drivers is 8,088, which is much larger than the number of drivers being selected, which is 4. Since the sample size is less than 5% of the total, so if we take 5% of the total, okay, if we take 5%, which is 0.05, and multiply that by 8088, that gives us 404. We can see that the sample size here, okay, 5% of that is much larger than 4. So since the sample size is less than 5%, then the calculations can be simplified by assuming that the events are independent. So we're going to multiply the probabilities of 4 independent choices to find the probability that 4 randomly selected high school drivers all drove when drinking alcohol, and then we're going to round it to 6 decimal places. So the probability that 4 high school drivers who drove when drinking alcohol is taking the fraction 835 over 8,088 times 835 over 8,088 4 times. So another way of saying this is that we can say 835 divided by 8,088 to the 4th power. So one way of doing this on the calculator is the following. You would say parentheses 835 divided by 8088, and then we're going to raise it to the 4th power, and that gives us 1.136007848, and this is times 10 to the negative 4. So that means we need to move this decimal place over to the left 4 times. And so therefore, that's going to give us 0.0001136, and we need to round it to 6 decimal places. So therefore, we're going to get approximately 0.000114. Let's go ahead and put that answer in here. So 0.000114. That would be the probability that 4 randomly selected high school drivers all drove when drinking alcohol is 0.000114.